Now that we've talked about whether or not a function is one-to-one, we can talk about inverse functions. So the inverse of a one-to-one function is another one-to-one function denoted with this f to the negative 1 power. Now it's not read as f to the negative 1 power, it's read as f inverse. So again, this f to the negative 1 power right here is read as f inverse. And what's happening is it's the set of all the ordered pairs yx where xy belongs to f. So every ordered pair that's in f gets flipped to x or to yx, and that is what makes up f inverse. Right? So let's look at some examples. This says find the inverse of the one-to-one function f equals 2, -4, -113, and 0, 0. So this function is just a set of ordered pairs. They've already told us it's one-to-one, but it must be one-to-one in order to have an inverse. And so we can find f inverse. Again, that's not something like you don't take the reciprocal, it's a function, and this is how we denote f inverse. It's going to be the set of all the ordered pairs where we change the order. So xy now becomes yx, -4, 2, and 13, -1. And 0, 0 is still 0, 0. So that's the f inverse, the set of those ordered pairs. Alright, let's look at this equation down here. It says find the equation of the inverse f of x equals 2x minus 5. So it doesn't tell us it's one-to-one, but any linear equation that's not horizontal or vertical line will be one-to-one. So we want to find f inverse. How do we do it? We have to flip the x and y. Remember, f of x is the same thing as y. So this is the same thing as y equals 2x minus 5. And that's just because f of x equals y. They're the same thing. Now I can flip my x and y. So I'm going to replace y with x. I'm going to replace x with y. And I want to solve this for y because that's how we write our functions. We write it as f of x equals. So to get y alone, I have to add 5 to both sides. X plus 5 equals 2y. I have to divide by 2. And then, so y equals, you could write it as x plus 5 over 2, or you could write it as 1/2 x plus 5/2. Either way. But we're going to take one last step because this equation is not the same as that equation. We're going to go back to our function notation and write f inverse of x equals, and I'm just going to pick the first one here, x plus 5 over 2. So you have to put in or put back the function notation and show this is function f, this is f inverse. Go ahead and try these two examples. So this one up here with the ordered pairs and this equation down here, trying to find the inverse function. Alright, back up here to this function f. It's made up of -2, 3, -1, 5, and 6, 7. The inverse function, so f inverse, will be the set of ordered pairs where xy becomes yx. So 3, -2, 5, -1, and 7, 6. That is f inverse. Alright, let's come down here to this function. G of x equals 3x minus 1 equals, or over 4. Remember, this is the same thing as saying y equals 3x minus 1 over 4. Then to find the inverse equation, I have to flip my x and y. So now x equals 3y minus 1 over 4. I need to solve for y, so I'm going to undo this division by multiplying both sides by 4. So that divides out. Now I have 4x equals 3y minus 1. I'm going to add 1 to both sides. Now it is 4x plus 1 equals 3y. Then I'm going to divide both sides by 3 to get y alone. Make sure you divide everything by 3. And I'm going to go back to my function notation. So instead of writing y, I'm going to write this was g inverse of x equals 4x plus 1 over 3. So all we did in that last step was replace y with g inverse. Because the original y was for g of x, this is for g inverse of x.